Whenever people hear about the heliosphere, I think a lot of us picture a sci-fi force field or something from Star Trek. But it's actually this massive bubble created by the sun, right?
Totally! The heliosphere is like our solar system's protective bubble, made by the sun's never-ending stream of charged particles, the solar wind. It stretches way past Pluto, wrapping all the planets in this gigantic shield.
That image blows my mind. So we're all cruising through space inside this sun-made bubble, while the solar wind rushes outward. But what's the solar wind exactly? Is it really just wind, like the kind we feel here on Earth?
Not quite. Solar wind is actually plasma, a soup of charged particles, not air. And as it streams out from the sun, it fills the solar system with radiation and magnetic fields that totally shape the space environment around us.
So, if the heliosphere acts sort of like a shield, what exactly is it protecting us from?
It's mainly galactic cosmic rays, super energetic particles from outside our solar system. Without the heliosphere, we'd be getting hit by way more of this cosmic radiation, which could mess with electronics, astronauts, and even our climate over really long timescales.
That's wild. I didn't realize there was this invisible battle going on just to keep us safe. And Earth has its own shield too, the magnetosphere, right?
Exactly. Earth's magnetic field is like a second layer of defense, blocking not just cosmic rays but also the sun's own charged particles. Planets like Mars and Venus don't have that, which is part of why their atmospheres evolved so differently and why Mars is so barren today.
Speaking of Mars, I remember reading about NASA's MAVEN mission studying the Martian atmosphere. How do missions like that help us understand the heliosphere?
Missions like MAVEN and Juno around Jupiter give us front-row seats to how solar wind interacts with different planets. By looking at what happens to atmospheres with and without magnetic fields, scientists can piece together how the sun shapes planetary environments and even what makes a planet habitable or not.
That actually reminds me when we hear about things like coronal mass ejections. That's the sun tossing out huge clouds of material, right? How does that affect the heliosphere?
Yeah, those are like solar storms. They stir up the space environment and can trigger space weather effects, even on Earth. It's all part of this dynamic system where the sun, planets, and the heliosphere interact in real time.
I'm fascinated by how we even know where the heliosphere ends. I mean, it's not like there's a giant wall out there. How do we figure out where that boundary is?
Great question. NASA has sent out missions like the Voyagers and the Interstellar Boundary Explorer IBEX to measure what's happening at the very edge, where the solar wind finally slows down and meets interstellar space. It's not a solid wall, but more like a fuzzy border where the sun's influence runs out.
It blows my mind that Voyager 1 and 2 are still sending back data from beyond that edge. Do these missions teach us anything about what lies outside our bubble?
Absolutely. There are eyes in interstellar space. By studying how the solar wind and cosmic rays behave at the boundary, we learn not just about our own neighborhood, but get clues about how other stars might shape their own planetary systems too.
So, the heliosphere isn't just some sun-centered oddity. It's a cosmic phenomenon that could tell us a lot about making planets habitable, even around distant stars.
Exactly. And that's why heliospheric science is so cross-disciplinary. Astrobiologists, astrophysicists, and space weather experts all have a stake in unraveling how these giant cosmic bubbles work.